Hello again, students, and this is the last section of Unit 6 on molecular symmetry, and we're going to see how all the symmetry elements and operators that we've looked at already, how they come together. Alright, so like I said in the previous section or part, that the molecules don't just have one symmetry operator, they have a number. They could have reflections, inversions, rotations, and their set of symmetry operations that are going to describe a molecule that has overall symmetry is called a point group. And if we were to look at mathematical treatment of the properties of these groups, we would be studying something called group theory. Now, point groups and symmetry can be used to determine molecular orbitals and vibrations. I think I mentioned saying that to you right back in part 1 of this unit. There are a number of steps to determining the point group, and I've listed them here for you, and I think I'm going to rather just show you a shortcut later on which may help you. So this is a step-by-step procedure that you would go through examining a molecule, and you will do this in greater detail in practical 5. But this just lists a number of steps that you would ask yourself some questions in order to determine the various symmetry elements of a molecule and ultimately determine its point group. Okay, so we have some strange notation that you might be seeing here. These kinds of things here. This is C1, CS, Ci. I'll explain that in a short while. And then we have these ones which you may recognize. This one here is tetrahedral. This one here is octahedral. And obviously that describes materials or molecules that are actually tetrahedral in geometry usually, or octahedral in geometry. And we'll get to the other ones, CV, DH, RH. That'll all become very clear to you later on, hopefully. And then, of course, like I said, you ask yourself a number of questions in a specific order. And there's a much nicer way of doing this, but I just wanted to detail the steps for you so that you could actually see the kinds of things that you would need to ask yourself in terms of determining the point group for a particular molecule. All right, so what are the various point groups? If there's no symmetry, so in other words, we just have the identity, then we have the point group C1. That is its grouping. It was set up by a scientist by the name of Schoenflies, and we'll have a look at this in a little while. If there is only one mirror plane, then we have the point group CS, and if there's only an inversion center, then we have the point group Ci. So most low symmetry molecules, we will also have a point group called C infinity V. Most of the molecules that are linear fit into this point group. They have infinite rotation and reflections, but no center of inversion. Okay, the D infinity V, the molecule is going to be linear. It will have an infinite rotation and reflection process. It will also have perpendicular C2 axes and mirror planes, and there will be an inversion center. The high symmetry molecules, we have tetrahedral, that's what TD stands for, and you can see there are lots of symmetry elements that are available. There are 4 C3 axes, 3 C2 axes, 3 S4 axes, and 6 sigma D mirror planes, but no C4 rotation. And if you remember how we treated methane in the previous part, you will remember that we had 3 S4 rotations that we had to deal with. Okay, OH is octahedral. There are 48 symmetry operations, including 4 C3 rotations, 3 C4 rotations, and an inversion. We've had a look at the inversion with the octahedral geometry already when I explained the inversion symmetry operator to you, I used an example of an octahedral molecule. And then there's one more called icosahedral, which is a 12-sided figure, if you were to look at such, and that's extremely high symmetry. It has 120 symmetry operations, including 6 C5 axes. Okay, the next couple of slides just demonstrate to you the point groups and the symmetry elements. I don't expect you to know this. I just want to use it for demonstration purposes to give you examples of point groups, symmetry elements, the geometrical shape, and some of the examples. The symbol that you see on the far left of the table here and here is called the Schoenflies symbol. Okay, so you see this is point group C1, C2, and so on and so forth, CS, C2V, C3V, C infinity V, and the examples are given accordingly. And we continue with the table, and you will see that the higher the symmetry you go up, the more symmetry elements you tend to find. So for example, the one that is designated here, D4H, you can see the various symmetry elements. So we have identity, 2 C4 rotations, a C2, a C2 prime, 2 C2 double primes, an inversion, 2 S4s, a horizontal mirror, 2 vertical mirror planes, and 2 diagonal mirror planes. It's very high, it's high symmetry. Okay, and just so that you can recognize what the point groups look like. Is this what the tables are there for? Like I said, you don't need to know the tables. You're going to be able to determine the point group of a molecule without the tables. Okay, how are we going to do it? Well, remember I said to you at the beginning of this, the start of this part of the unit, that there was a procedure. Well, there's a flow chart which will help you. So you need to start at this point over here. And then you need to ask yourself some questions. You need to ask, is the molecule linear? Yes or no? Okay, and so you go forth, working through each individual question as you go, following the procedure as you go, until you eventually end up with a point group. Now the point groups are designated in these yellow circles in this particular flowchart. Okay, this is one way that we can ask questions. There are 2 flowcharts. I'm going to show you the second one now. So these are the point groups here in these yellow colored circles, and you can see that these are the high symmetry ones down here that I've just highlighted, and then of course the rest of them are there. Okay, the second diagram is also a flowchart. It also asks questions, and it also gives you the same information. And what I'm going to do is, for an assessment, you will be provided with both of these flowcharts. So you can choose for yourself which one you want to use to determine the point group of a molecule, because that's the simplest thing for me to ask you to understand whether you understand symmetry is, can you determine the point group of a molecule? Okay, there are lots of examples that you can do. So for example, carbon dioxide has the point group D infinity H, and the way we get to that point group is that we ask ourselves questions from that flow chart. Okay, now in order for us to solve these examples, you would need to have the flow chart with you, and you would need to ask yourself various questions. Now, as I mentioned previously, you will be doing a practical on this, and you're going to get lots of practice with doing this. There are about 10 examples in the practical, and there's a website that you're going to go to that you can access the practical and follow the instructions that I've given you to actually determining point groups. And you will go through all the symmetry elements and operators again, so that hopefully you will gain a much better understanding of symmetry as a whole in molecules. I hope that this has been helpful, and this concludes Unit 6.